Greetings and welcome. In this session, we will see a numerical on Pitot tube. In the last video session, we have studied construction and working principle of a Pitot tube along with expression for velocity of fluid flow passing through a pipe. In this session, we are going to see a numerical on a Pitot tube to calculate the rate of flow of water through pipe. So let us see a statement given. A Pitot tube is inserted in a pipe of 300 mm diameter. The static pressure in pipe is 100 mm of mercury, that is vacuum. The stagnation pressure at the center of pipe recorded by the Pitot tube is 0.981 Newton per centimeter square. Calculate the rate of flow of water through pipe if the mean velocity of flow is 0.85 times the central velocity. Take the value of CV, that is hydraulic coefficient, 0.98. So let us elaborate this data with the help of diagram. So here is a schematic diagram of Pitot tube. This is a pipe flow. Pipe diameter is given D 300 mm. For the calculation purpose, we convert that into meter. So that is, it comes D is equal to 0.3 meter. On the pipe, to measure the static pressure head, here is a piezometer fitment. So it shows HO, that is a static pressure head, at point number 1, which is called a static point. This is a Pitot tube, that is a small tube bent at right angle, located at point 2, which is called a stagnation point. It shows stagnation pressure head HS, and difference between these two, that is HS minus HO, is H, which is called as differential head of the Pitot tube. So fluid flowing through this pipe is given as a water. So that is why for the calculation purpose we use specific weight of water, that is 9810 Newton per meter cube. In the given data, static pressure head HO is given 100 mm of Hg, vacuum. So the value which is given here is in terms of mercury and it is in vacuum form. So let us convert that into meter. So 100 mm divided by 1000 will be equal to 0.1 meter of mercury, vacuum. As vacuum, negative sign. Now we have to convert this value from mercury column to water column. So for that purpose we can use this formula. Now this formula is based on the concept in a fluid mechanics module first, that is a fluid properties. There we have seen density of water is 1000 kg per meter cube and density of mercury is 13,600 kg per meter cube. Means here density of mercury is 13.6 times the density of water. Means mercury is 13.6 heavier than the water. So that is why here we can use that concept here to calculate the static pressure head in water column. We can write static pressure for water is equal to static pressure for mercury multiplied by specific gravity of mercury. So here HO for mercury we have got minus 0.1, we use it here, multiplied by specific gravity of mercury, that is 13.6. After the calculation we get static pressure head in water column, that is HO is equal to minus 1.36 meter. Next, stagnation pressure means PS, that is given 0.981 Newton per centimeter square. We convert that into meter, Newton per meter square. for the calculation purpose. So here we write 0.981 multiplied by 10 raised to 4. This PS value we use to calculate the stagnation pressure head HS is equal to by using this formula. So HS equal to PS by W, value of PS calculated 0.981 into 10 raised to 4 divided by specific weight of water 9810 Newton per meter cube. So doing the calculation, we get stagnation pressure head in a water column, that is 1 meter. Then we calculate differential head of the Pitot tube, that is as per the diagram H is equal to HS minus HO. So putting the value of HS here, HO calculated in last slide, that is a negative. So finally by doing this calculation we get H, that is a differential head in water column 2.36 meter. We use this H value to calculate velocity of water at center. Its formula is CV into square root of 2gh, that is as per the expression for velocity of the Pitot tube. So CV into square root of 2gh, CV value is given 0.98 multiplied by inside the square root 2 multiplied by g value 9.81 multiplied by value of h 2.36. Doing the calculation, we get velocity at center 6.668 meter per second. Now, in the statement, mean velocity of a flow, that is a V bar, given 0.85 times velocity at center. So putting velocity at center, this value here, so 0.85 multiplied by this 6.668, we get the value of V bar, that is 5.6678 meter per second. To calculate rate of flow, that is a discharge of water passing through the pipe, that is equal to area into velocity. So pipe area is a pi by 4 into d square multiplied velocity is a mean velocity, that is V bar. Putting the value of diameter in a meter and V bar calculated over here. So doing this calculation, we get the value of rate of flow of water, that is a discharge passing through a pipe 0.4005 in meter cube per second, which is asked in a statement. So in this way we have solved a numerical on a Pitot tube where we calculated the differential pressure head with the help of data and diagram. After that we use that to calculate the velocity. Then that velocity we use to calculate the flow rate of water. And finally we find the discharge of water passing through the pipeline. Let us meet in the next video session. Thank you.